So the screen is visible, I hope, right? Yes. Okay. Am I audible? Hello? Hello? Audible? Okay.
Yes, ma'am.
Okay, fine. Okay, so let's start today's session. Yeah. So today we will talk about the assignment 11 previous year question paper for the course nuclear and particle physics. And there will be, I think, 8 questions for today's session. So let's start. The first question is, which of the following statements is or are correct? The first statement is photon can take part in electromagnetic interaction. Photon can take part in weak interaction. Photon can directly interact with gluons. Photon can directly interact with quarks. So this lecture, I mean, in that week, Professor Paulus told about how photon can interact in different forces, right? Like in electromagnetic forces, weak interaction, weak forces, strong forces, and the gravitational forces. Obviously, first of all, photon obviously take part in electromagnetic interaction because photon is the mediator for the electromagnetic interaction. Okay, so they are asking in that question that which of the following statements is or are correct. That means among these 4 statements, maybe one or more than one option will be correct. So first of all, whatever it is written here in option E, that is photon can take part in electromagnetic interaction, that will be exactly correct because photon is the main mediator of electromagnetic interaction. So if I write here, this one will be the correct one first of all. Now come to the second one. Photon can take part in weak interaction. So basically photon can interact with weak interaction, that will not be correct because in weak interaction, who are the mediators? W plus, W minus and Z0. These 3 are the Z0. These 3 will be the mediator for the weak interaction, and photon cannot interact with, cannot take part in weak interaction. That will not be the correct one. Now come to the third one. Photon can directly interact with gluons. Obviously not. So photon cannot directly interact with gluons. That will also not be possible. Photon can directly interact with quarks. That is possible because let me tell you, like U. So U, D or something. These are quarks, right? And these are non-zero charge particle. Non-zero charge particle means it has a charge as plus 2 by 3 E. And what is this one? Minus 1 by 3 E. So as this U and this D has charge under electromagnetic interaction, that means obviously photon can take part directly in the interaction with quarks because the quarks are charged under electromagnetic interaction. Charge under electromagnetic interaction means it has charge which is Q, and the Q value is non-zero for U, D and all these quarks, right? So that's why we can tell that photon can take part in electromagnetic interaction, photon can directly interact with quarks, and these 2 will not be the correct one. So the main conclusion from this first question can be written as photon can interact with these particles which yes. Okay. So photon can interact with these particles which has non-zero value of EM charges. So photon can only interact with this particle which has the non-zero value of EM charges. Now you can see that obviously our leptons, that means E minus, mu minus, tau minus, then let's say our quarks Q, that means U, D, C, T, P and 1, 2, 3, 4 S. These 6 have charges Q. These 3 also has these 3 also has a charges which is non-zero. So that's why these leptons as well as these quarks can interact with photon gamma. Okay, so that means whatever it is given in that question, the correct answer will be it can interact with electromagnetic interaction, it can also interact with quarks, and these two will not be the correct one. So A and D will be the correct one. Okay, so whenever in our question or something, whenever you will see any charged particle which has non-zero value of Q, that should interact with photon. Something is there, let me see. Okay, nothing. Okay, so this is the first question, right? Now coming to the second question. Which of the following statements is or are correct? So what is this question? W boson can take part in electromagnetic interaction. W boson Rama, can you please mute yourself? Okay, thank you. Yeah. So which of the following statements is or are correct? First one is W boson can take part in electromagnetic interaction. W boson can take part in weak interactions. W boson can directly interact with gluons, and W boson can directly interact with quarks. You can see that these 4 options are exactly same whatever it was given in the previous question. So basically we are asking about that W boson can interact or take part in which interaction. That is the main question. So now previously it was gamma, that means photon. Now we are talking about W boson. So first of all I told you that W boson can take part in weak interaction, because in weak interaction the mediators are W plus, W minus, Z0. Now you can see that W plus, W minus can be called as W boson. So if it is W boson, then obviously it will take part in the weak interaction. Okay, so first of all, as a very straightforward, we can tell that the B option will be the correct one. Now coming to the D and A and C options. So I am talking about D option first. W boson can directly interact with quarks. Okay, so W boson means you can see it is W plus, W minus. That means whenever it will be in our equation, nuclear interaction, then as it is plus and minus in charge, it will interact in only on these particles which are charged under Q, right? Otherwise, like let's say our B is going to D. Now you can see that B is plus 2 by 3E and D is minus 1 by 3E. Now how 2 by 3E can go to minus 1 by 3? If I do like U, D, and let's say this is W minus, then what will happen? U is plus 2 by 3E, W minus is minus 1 into E. Then you can just calculate it, it will be like minus 1 into E, which has the Q value of D, D particle, right? So that means whenever the quark will be present in our interaction, the W boson can take part in that weak interaction, in that interaction. So that means the W can take part in quark as well. Okay. Similarly also you can see that D bar going, U bar going to D bar. So U bar going to D bar. U bar you can see it is minus 2 by 3E and D bar is 1 by 3E because it is bar. So minus 2 by 3E to 1 by 3E. How it can be possible? W minus. Then I think W plus, because minus 2 by 3 plus 1. Then what will be the value it is? It will be 1 by 3. So minus 2 by 3 plus 1, E can go to 1 by 3 E. That means our quark or antiquark can be changed their flavor with the help of W plus or W minus, which is nothing but W boson. So the fourth option will also be the correct one. Now coming to first option, W boson can take part in electromagnetic interaction. Okay, so for this case, I can tell you electromagnetic interaction is like, okay, electromagnetic interaction. In that electromagnetic interaction, what is happening? In that electromagnetic interaction is nothing but where EM charge, that is Q, changes, right? So you can see, if I just take the same example, that U is going to D. So U has a Q value as 2 by 3E and it is going as minus 1 by 3E. That means what? The charge, EM charge is changing in this expression, in this reaction. So it is nothing but a EM interaction. So in that EM interaction, you can see I already told you that U to D, that can be possible via W minus, because 2 by 3 minus 1 E is minus 1 by 3. So you can also tell that our electromagnetic interaction, our W boson can take part, because it is changing our Q value from plus 2 by 3 E to minus 1 by 3 E. Okay, so as a summary, I can tell W boson can take part in EM interaction. Okay, basically in EM interaction means I am talking about electromagnetic interaction. I am just reading it like short form, electromagnetic interaction. The second one will be can directly interact with quarks. Quarks. And the third one will be can directly take part in weak interaction. Weak interaction. So these three options can be correct. Now coming to the fourth option, whatever it is given here. Yes, I mean that C. Now we have already discussed about A. Now coming to C option. W boson can directly interact with gluons. That will not be possible, because gluons is like only, gluons is what? Gluons is the mediator itself, and that gluons has a property that it can interact with itself only, like that and like that. That means gluon can interact itself, but it can't interact with W boson directly. So it will not be the correct one. So the correct options are A, B and D. Okay, so these three will be the correct option for question number 2. Okay, so we will go to the next question. Yes, this is the next question. Find the missing particle in E plus mu E going to mu plus dash. And there will be 4 options: mu E bar, mu bar and mu E. So which one will be the correct one? So first of all, I just want to write here E plus mu E going to mu plus what? Now you can see that this nuclear interaction is nothing but a weak interaction. Why? Because in that interaction neutrino is present. Neutrino is present. So if it is weak interaction, and I mean, like, how we can say that this is a weak interaction? in this in that nuclear interaction, neutrino is present in any, either left hand side or right hand side, in any particle configuration neutrino is present. So that's why we can tell definitely that this expression will be nothing but a weak interaction. And in weak interaction we can have like some constraints. Like first constraints means like obviously B, L, Q, these three things will be conjugate. That will be for everyone, as I told previously also, conjugate. And the second one, which is the most important for weak interaction basically, that is Le, L mu, L tau. These three will be conjugate separately and individually. I will tell you what is the meaning of this separately, independently, independently. So what is the meaning of this one basically? So you can see that first of all, what is this one? B means baryon number, L lepton number, and Q is electromagnetic charge. So baryon number, lepton number, and electromagnetic charge should be conjugate in any nuclear reaction. That is the very basic criteria for any type of nuclear reaction. And what is second one? Second one means Le, electron type lepton number, muon type lepton number, and tau type lepton number should be conjugate separately and independently. Now come to the equation first. What was the equation? It was like this one, and it is like mu plus something. Let's say it is x. I am writing here it is x. Yes. So now what will be the value of x? First of all, what is the first condition? B, L, and Q should be conjugate. So what is the conclusion from this criteria? Let me tell you. First of all, we will talk about baryon number, E plus, mu plus, and let's say x. So baryon number for mu E plus is 0, mu E is also 0, and then mu plus is also 0. So obviously the del x we should not be a baryon, because our delta B should be 0. Okay, first condition has done. Now coming to L. L means lepton number. This lepton number is nothing but any of the electron type, muon type, or tau type. So here E plus has the lepton number -1. Nu E has lepton number +1. Right? Okay, I am just putting here one line. And what is mu plus? Mu plus has lepton number -1. Then what should be the lepton number for H? It should be +1. Otherwise delta L should not be 0. You can see -1 +1 -1 +1. So that means we can have one conclusion from this. B of x is 0, L of x is 1. Now coming to charge, electromagnetic charge. You can see here the charge of E plus is 1, mu E 0, mu plus 1. So delta x should be, del q of x should be 0, because delta q should be 0. So what is the conclusion from here also? Q of x is 0. So these are the first, these are coming from the first assumption. Now coming to the second assumption. The second assumption, not assumption basically, it is the criteria. So the criteria was Le, L mu, L tau should be conjugate separately and independently. Okay, so let us first consider about Le. Le means what? Only electron type lepton number. So for electron type lepton number, E plus will be -1. Nu E will be 1, right? But mu plus does not have any electron type lepton number. It has muon type lepton number. So for electron type lepton number consideration, it will be 0. And what will be about the x? Because our delta Le should be 0. So separately independently means separately each and every Le, L mu, L tau should be conserved, and independently means there will be no dependency among these three lepton numbers. So I am just talking about Le right now. So that means delta Le should be 0. So now you can see here the left hand side is -1 plus 1 as a whole 0, and the right hand side is already 0. So that means our x should have a 0 value. So Le of x should be 0. Now coming to L mu value. L mu will be what? For E plus it is 0, mu E 0. Now coming to mu plus. For mu plus it is -1. And what will be the x value? Obviously it will be +1. Otherwise the left hand side is 0 and the right hand side should be 0. So obviously it will be 1. So delta L mu equals to 0 and L mu x equals to 1. Now coming to L tau. L tau means you can see here that E plus, mu E, mu plus, these three are not tau. So that means all the things will be 0. As these are 0, that means our this one will also be 0. So L tau of x will be 0. Now we have so many quantum charges of x. B of x is 0, L of x is 1, Q of x is 0, Le of x is 0, L mu of x is 1, L tau of x is 0. So first of all, as it is weak interaction and there are so many quantum charges we already got from that nuclear interaction, we can have a idea that what particle will be x. How? Okay, so first of all, it will not be a baryon, right? It will be a lepton because it is a non-zero under lepton. Okay, and it does not have any charge under electromagnetic interaction. It also, okay, so that means our conclusion from these three is like x is lepton. Now coming to which type of lepton it is. Is it electron, is it muon, or is it tau type lepton? To answer this question, you can see here it is not a electron type lepton. It is a mu type lepton. It is not a tau type lepton. So in mu type lepton, how many? So mu type. So how many mu type leptons are there? We know that the leptons in mu category there is mu plus, mu minus, mu bar. These four are there. Now coming to this one, Qx is 0. That means it should not have any charge. So that means these two will not be the correct one. Now maybe mu or mu bar will be there. Now coming to this option, L mu of x is 1. So that means among these two, which one has L mu equals to 1? That will be the correct one. Now coming here, nu mu has 1, mu bar has -1. So which one will be the correct one? The correct one will be mu. Okay, so just we have to see that which expression will be the correct one, and from that knowledge we can have some idea about the x property, I mean the particles property under some charges, and after diagonalizing this, I mean explaining these charges, we can have an idea that our x particle, whatever it is given here, that will be mu. So what is the answer here? The answer will be B. Okay, so I think it's understandable, or if you have any question you can ask me, or we can go to the next question. Okay, so we will go to the next question. Select all possibilities. The process U goes to D bar, I mean U plus D bar goes to U plus D bar is mediated by which particles? Is it W boson? Is it photon? Is it Z boson? Or is it gluon? Okay. Okay. So first of all, U plus D bar going to U plus D bar. Now you can see that left hand side, what is the Q here? Obviously this 2 by 3, this is 1 by 3, this is 2 by 3, this is 1 by 3, and also U is going as U itself, D bar is going as D bar itself. So it can be possible that this process is mediated by Z 0, because it is a neutral particle, neutral gauge boson, and U plus D bar, that means obviously there should be some mediator which is neutral. So Z boson can be the correct option. Now coming to photon, I told you in the two previous question that photon can only interact with charged particles. Charged particles means which are charged, which are charged under EM interaction. So you can see that U, D bar, these two are obviously charged particle under EM, because these two particles have charge which is non-zero. So Q for D as well as Q for D bar, Q for D bar are not equals to 0. That means our photon can also be the correct one. So Z boson, photon, and then W boson. Okay, so W boson means I can tell you, is it a correct or not. Let's say U plus D bar going to U plus D bar. So if let's say W plus is mediating this process, then what will happen? U will go to which one? Obviously there will be no particle like that, because you can see that this is 2 by 3, and if I add this, let's say W plus means 1, so it is 5 by 3, and 5 by 3 means there will be no particle like that. So you cannot go with U or D bar with the help of via W plus. Now coming to W minus, you can go, you can interact via W minus to give what? You can see that if I do like that, then it will give minus 1. That means you can go to D, not you can go to D bar, because D bar has the charge plus 1 by 3E. So U cannot interact with W plus as well as W minus to give U and D bar, right? Similarly, if I do the same thing with D bar also, D bar, let's say it is going to U or D bar via W plus or W minus. So it is 1 by 3E, and this is 2 by 3E, and it is 1 by 3E. Now let's say W plus I am applying. So if I am applying W plus, then what will happen? 1 by 3 plus 1. That means it will be 4 by 3. You can see W 2 by 3 and 1 by 3. So that means there will be no one which is 4 by 3. Now coming to W minus case. 1 by 3 minus 1. It is minus 2 by 3. Obviously again 2 by 3 and 1 by 3 is not there. So that means minus 2 by 3 will not be the correct one. So the conclusion will be like W plus or W minus cannot interact in that interaction. Cannot mediate in this process. So W minus will be the wrong answer. Now coming to gluon. Okay, so gluon is what? Gluon is mediator of strong interaction. Okay, so if it is a mediator of a strong interaction and U, D bar, these things are participate in strong interaction. So that means our gluon can be the mediator of this process U plus D bar going to U plus D bar. So the correct answer will be what? A, B and D. Because in the process, select all possibilities. That means we have to see how many maximum number of options are applicable in this process. The process U plus D bar going to U plus D bar is mediated by Z boson, photon, gluon, and probably boson will not be the correct one. Okay, so this is the question number 4. Now we have to go back, we have to go to the question number 5. Okay, so which of the following interactions are not allowed? Very simple question, and there are 4 options. U plus U bar going to E plus E minus, U plus E minus going to mu E bar plus D, U plus D bar going to E plus E minus, U plus E plus going to mu E bar plus D. So first of all, in any nuclear reaction, it will be allowed or not. I told you that B, L and Q should be conserved, and if it is weak interaction, then I told you that Le, L mu, L tau should be conserved independently and separately. So first of all, let me tell you that one, U plus U bar, E plus E minus, U plus U bar, E plus E minus. Now you can see that if I talk about baryon number, then the baryon is like U is a baryon which is 1, U bar is antibaryon -1, E plus is not baryon, E minus is also not baryon. So as a whole, delta V can be 0. That is fine. Now L means it can be any type of lepton. U is not lepton, U bar is not lepton, but E plus is lepton -1, E minus is lepton. So as a whole, it is delta L 0. Now coming to Q. Okay, so what was that? U plus U bar. U means 2 by 3, U bar means minus 2 by 3. E plus E minus, plus 1 minus 1. So as a whole, delta Q is 0. So from that first expression, you can see that B, L, Q all are conserved in that expression. Now coming to element, okay, so it cannot be a weak interaction. So Le, L mu, L tau, we should not see that one right now. And also if you want to see that also, no problematic. That means Le means you can see that Le means it will be 0, 0, this will be -1, this will be +1. So as a whole, delta LV should be 0. Okay, so I can tell you roughly that the first one is allowed. Now coming to second one. Second one is what? U plus E bar, mu E bar plus D. U plus E minus, mu E bar plus D. So B 1, 0, 0, 1. It is correct. L 0, 1, minus 1, 0. Now you can see that delta L is not equals to 0. And Q 2 by 3 minus 1. This one is correct, but in any nuclear interaction, delta L should be equals to 0. So that means our B is not allowed. Okay. Now coming to C option. U plus D bar, E plus E minus. U plus D bar, E plus E minus. Okay. B plus 1 minus 1 0 0, fine. L 0 0 minus 1 plus 1, that is also fine. Now coming to Q value, this is 2 by 3, 1 by 3 plus 1 minus 1. Now you can see that the plus 1 minus 1 can give you 0, but 2 by 3 plus 1 by 3 it will give 1. So that means delta Q is not equals to 0. As delta Q is not equals to 0, our C is not allowed. Okay. Now coming to D. What is D option? U plus E plus mu E bar plus D. U plus E plus U plus E plus U plus E plus going to mu E bar plus D. Mu E bar plus D. Now here also we can see that B first. 1 0 0 1. Delta B is fine. L 0 minus 1. This is plus 1. This is 0. Now you can see that delta L is not equals to 0, because here it is minus 1 and here it is plus 1. So that means delta L is not equals to 0, which tells us that echo is not allowed. So which one, how many processes are not allowed? B, C, D. These three are not allowed. So if I write here, the correct answer will be B, C, D. Okay. So this is the one. Okay. So coming to the sixth question. Which of the following processes are solely mediated by Z boson? And there are 4 options. What are the options? Mu plus mu minus going to mu E mu bar. Mu plus mu minus going to mu bar. E plus E mu bar going to E plus, mu plus mu bar going to E plus mu bar. Mu plus mu bar going to E plus mu bar. Okay. So solely mediated by Z boson, that means only and only Z boson will be the one mediator, one and only one mediator in that process. Okay, so this one we have to mention which one is like that. So first of all, what is there? Let's say mu plus mu minus going to mu E bar. So you can see that mu plus mu minus, these are going to mu E bar. So first of all, we just want to check a little bit quickly that B, L, Q are exactly conserved or not, because we are talking about nuclear interaction, and if it is allowed, then only we can tell is it solely mediated by Z or not. So mu plus mu minus goes to E plus mu E plus mu E bar. In that case, our B has 0 0 0 0, L has plus 1 minus 1, minus 1 plus 1, 1 minus 1, that is fine. L 1 minus 1 0 0, that is also fine. So B, L, Q are also fine. Now as it is already neutrino is present in this expression, so that means we have to consider weak interaction case. That means L E, L mu, L tau. So L E 0 0 1 minus 1, fine. L mu minus 1 1 0 0, fine. L tau 0 0 0 0. So as a whole, all the conditions are satisfied. That means mu plus mu minus going to mu E plus mu e bar, that is possible. Now possible by which interaction, that we have to tell. Okay, so if I write here Feynman diagram, mu plus mu minus, and here mu e bar, then if you see here, that will be nothing but z. Why? Because w plus w minus, this vertex will give a charge 0 and z has also a charge 0, that means it will go as like that, and then at this point mu e bar all has the all have the charge as 0. So that means this Feynman diagram can be the correct one. Okay, now let's say I am talking about w plus w minus and all these things, so it will not be the correct one, because w plus w minus means that should change the charge of this particle as like u to t, but here in that vertex mu plus mu minus is coming and it is producing mu e bar, so that means it can be mediated by z. Okay, so it is z mediated by z. Now coming to the option number B, mu plus mu minus mu bar, mu plus mu minus mu bar. First of all, let me tell you quickly these things. Then B 0 0 0 0, L minus 1 1 1 minus 1, Q 1 minus 1 0 0. Okay, all the things are fine. Now as it is neutral, so that means we have to calculate L e minus L e, L mu, L tau. L is 0 0, 1 minus 1, L mu is 1 minus 1 0 0, L tau is 0 0 0 0. These all are fine, that means that is allowed at least. So mu plus mu minus goes to mu bar. So how it can be possible? First of all, one possibility is like mu plus mu minus mu bar, this through z. This can be possible. Another one possibility is like mu plus is going as, okay, mu minus is going as mu. Okay, so how it can be possible? It can be possible via w, because you can see that here minus 1 is coming and 0 is going, right? So there will be like, let's say, minus 1. So w minus is going from here to here and mu minus is going there. Similarly, if I do like mu plus, which is 2 by mu plus, that means 1 minus 1, which is 0. So you can see that w minus and mu plus can give you mu bar. So these two Feynman diagram are possible for mu plus mu minus going to z, mu bar. Okay, now coming to the C option. What is C option? The C option is, let's say, mu plus mu e bar, e plus mu e bar, mu plus mu e bar, e plus mu e bar. Okay, so in that question you can see, just quickly we will talk about L key view. B is like 0 0, all are 0. L minus 1 minus 1 minus 1 minus 1, that is also fine. Q 1 0 1 0, that is fine. Now you can see that the mu e bar is present in our nuclear interaction, that means it will be a weak interaction. So L e, L mu, L tau. L e is, okay, so the first one is 0. L e means mu e bar. Mu e bar has L e as minus 1. E plus as plus 1, sorry, minus 1. and nu e bar is also -1. Now you can see that 0 minus 1 minus 1 minus 1, that means the delta LE is not equals to 0. Similarly for L mu case, it is -1 0 0 0. So for L mu also, delta L mu is not equals to 0. For L tau, all are 0. So that means that is fine. So the C is at least, C is not possible in our nuclear reaction configuration. So there is no point to have the mediator as Z or post W. Right? Now coming to the last option, mu plus going to mu plus mu e bar e plus mu bar. Okay, I am writing here mu plus mu e bar e plus mu bar. So for that case, I just want to take a little bit B, L and Q. B is 0 0 0 0, L -1 -1 -1 -1. That is fine. What about Q? Q is +1 0 +1 0. That is fine. Now as it is neutrino present, that means LE, L mu, L tau. So for LE it is 0. So LE is -1, E plus has -1, L mu bar is 0. What is L mu? L mu has -1 0 0 -1. So these two are fine. L tau 0 0 0 0. So that means this process is allowed. Now we have to tell me this process is mediated by Z or something else. So mu plus and nu E bar and E plus nu mu bar. So I can write like that, mu plus is going to nu mu bar and then nu E bar is going to E plus. So which one will be the mediator? Obviously W boson will be the mediator. And which W boson? Let me tell you this arrow, then it will be like this is +1 and that will be minus, so that it will be 0. Similarly it is 0 and the minus is okay, so +1, and if it is coming like that, then it will be plus because it is going down, and the 0 is coming and the plus is coming, so E plus is going out. So that is fine. So that means in this process W is mediated, not Z. Now as we told that among these four processes, the first one is solely mediated by Z, second one is mediated by Z as well as W, third one is not even allowed, and the fourth one is mediated by W. So whatever the question asks, which one will be the solely mediated by Z boson, the correct answer will be A. Okay. So this is, I think, question number 6. Now come to the next question. Yes. Which of the following processes are solely mediated by W boson? And there are 4 options: mu plus mu minus mu e bar, mu plus mu minus mu bar, mu plus mu e bar, E plus mu e bar, mu plus mu e bar, E plus mu bar. I think these 4 options are exactly same whatever we right now did. So I can clearly tell that the C option is not even allowed, and the rest of the 3 will be allowed, but with which interaction? Let's say mu plus mu minus mu plus mu minus mu plus mu minus mu e bar, and it is Z. Mu plus mu minus mu bar. So mu plus mu minus mu bar, it will be Z, as well as mu plus, let's say mu minus mu bar through W. and the third will be, a fourth will be mu plus nu e bar e plus nu bar, mu plus nu bar e, what was that, nu e bar e plus nu e bar e plus, that is mediated by W. Now you can see that this process mu plus nu e bar goes to nu bar e plus. This process is solely mediated by W, and other two, that means this one is a mixture of Z as well as W, this one is solely Z. So that means our correct answer, which is asking for the solely mediated process by W minus boson, will be the D option, right? Because we have already seen that this one will be the solely mediated process by W minus boson. Okay, so this is the 7th question. Now coming to 8th question. Pi plus goes to E plus nu e bar. This decay is mediated by which? W boson, Z boson, gluon or photon. It may be more than one option also. So now first of all we will write pi plus goes to E plus nu e bar. First of all we will check, is it allowed or not. It may be possible that it is not allowed. So pi plus E plus nu e bar B L Q. Quickly we will check. B means it is not baryon, not baryon, not baryon. L not lepton, -1. Okay. E plus and nu e bar will not be there. Actually that should be nu e, otherwise it will not be correct one. Okay, so there will be nothing like that, so it will be 1, so that you can see that our L will be delta L equals to 0. Now coming to Q, 1 1 0, so all the three are satisfied. I am just going to remove this one. Because if in any time E plus is coming, then along with that nu E is coming, not nu E bar. If E minus is there, they coming, then only nu E bar will come. Okay, now as nu E is coming, so that means quickly we will take up nu tau process, I mean charges. So for LE means it will be 0, -1, +1, 0 0 0 0 0 0, right? So you can see that all of these things are conjunct. That means pi plus goes to E plus nu E. This process is allowed. Now by which mediator it will be allowed, that we have to check. So how many options are there? W, Z, gluon, photon. Okay, W, Z, gluon, photon. And what was the process? Okay, the process is pi plus E plus nu E. Okay. Okay, so now you can see that pi plus goes to E plus nu E. Yeah. So the W boson. Okay. If it is W boson, then what will happen? Pi plus can go to nu E, right? So it will be mediated by W plus, because it is a weak interaction, as neutrino is present here, and the mediator for weak interactions are W plus or W minus or Z0. But Z0 it can't be possible, because you know that, like, Z0 means what? Z0 means like there will be similar particle in the left hand side, and in the right hand side there will be similar particle. But here in this case it is not like that. So that means our Okay, so that means our process, whatever pi plus is going to E plus nu E, will be mediated by W boson. So the W1 will be the correct one. Now Z, as I told you, the Z will not be the correct one. Now coming to gluon and photon. So gluon is what? Gluon is participated in strong interaction, and it is not strong interaction because neutrino is present in this case. So that means gluon will not be the correct one. Now coming to the photon. Okay, so photon will be when at this time, let's say our pi plus pi minus is going to E plus E minus. In that process, photon can be take place. But as it is a decay process, as like E plus nu E, in that case, photon will also not be the correct one. So that option will not be the also correct. So the correct one will be only W boson. This one will be the only one which will decay, which will be the mediator for the decay of pi plus goes to E plus nu E. So pi plus goes to E plus nu E decay is mediated by a W boson, and it is not a Z boson, it is not a gluon, it is not a photon. So the correct option will be E. Okay, so these are the 8 questions for, I think there is no more question. No, there is no more question. So these are the 8 questions for this assignment number 11, previous year assignment questions. So if you have any doubt, then you can ask me. I am just going through each and every question as a revision so that you can understand clearly. This is the first question, and the answer is also written here. These two are the answers. Now coming to the second question. This is the second question. The answers are given here. In this case, the answers are these. Now the third question is this one, and the answer is this one. Fourth question is this one. The answers are, okay, I think I did not write here explicitly the answer. Yeah, I have written here. These are the answers. Now next, this is the fifth question, and the answers are these three. Now the sixth question is this one, and the answer is this one. Okay, and seventh question has the answer this one. Eighth question is the this is the question, and the answer is this one. So these are the total 8 questions of previous year assignment in week number 11. So I have just explained that one explicitly. If you have any doubt, you can ask me. Or if there is nothing as a discussion or something, then we will meet in the next class. I think the next class will be next week, Sunday, and this will be the last one for week 12. As it is a 12-week course, that means that will be the last one. So if you have any question, or you can go to the okay. So if you have any question, you can ask me. And I will upload that recording session in YouTube as well, as you all know these things. And I will also save, I will also share that PPT in the Google Drive as well after this class, so that it will be very much beneficial for all of you. Okay, so I think there is not that much any questions. If there is something, you can ask me. You can give some comment also, no problem. Or we will meet in next class. Okay, so if there is no questions, then we can stop today's class and we will meet in the next class. Okay, bye bye.